Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. Okay, today in this video we continue about chapter 8 about the example 8.3. Okay, from the Shigley Mechanical Engineering Design book. Okay, all the content is taken from that book itself and the images is taken from Google Images. So example 8.3. It says that 3/4 or inch 16 UNF times 2.5 inch grade SAE grade 5 bolt is subject to a load P of 6 kip in a tension bolt. The initial bolt tension is Fi equal to 35 kip and the bolt and joint resistance are Kb. Okay, Kb is the bolt stiffness, 6.5, and Km is the member stiffness, is 13.8 megapounds per inch respectively. Okay, number A is determine the preload and service load stresses in the bolt and compare this to the SAE minimum proof strength of the bolt. B is to specify the torque necessary to develop the preload using equation 8 to 7, and C is specify the torque necessary to develop the preload using equation 8.26 with F equals to FC equals to 0.15. Okay, so before I continue, I just want to tell about KIP unit. For those who are not familiar with KIP unit, Malaysian, we do not use KIP unit. For the US product, maybe you are dealing with US product. You may deal with the US customer that uses KIP unit. Okay, so KIP is used in USA, United States of America. Is unit for force. The unit is Newton. Okay, KIP equals to 1,000 pound. Okay, more or less 1,000 pound. The 1 KIP equals to 4.4482 kilonewton. Exactly, plus minus 4.482 Newton. Okay, you can convert to Newton. 1 KIP equals to 4.482 Newton. Okay, so uh, for the solution A, they want us to calculate the preload and service load. Okay, the preload stress is initial load equal to initial force over area of thread. Okay, equal to 25 given in the question. Over area of thread is from table 82. Area of thread is 0.373 inch. Okay, inch square. Given in, meaning that the thread they have the unit. Okay, from the table given from catalog from the company, they already have the sizes. You worst come to worst, if you do not have the catalog with you, take the micrometer and measure it. Okay, measure the diameter of the area of that thread. Okay, area of that thread. So you get 67.02 kpsi, kilo kpsi lah, the unit. Okay, the stiffness constant represented by the word C is kb. Kb is stiffness of the bolt. Okay, of the bolt. And km is the stiffness of the member. What is the member? Member is the, maybe is the washer and maybe is the nut. Okay, that is the member of the that bolt. So 6.5 over 6.5 plus 13.8, you get 0.320. And equation 8 to 4, meaning that stress under service load is okay, stress B, bearing stress FB equals to no, not the bearing stress, stress of the bolt equal to FB over thread, area of thread. So Cp is the stiffness coefficient and B is the um, P is the external load. You remember the chapter on external load? Okay, remember that I put, okay, meaning that I giving the external load with my hand. I give load to that what this whiteboard. My load from my hand is the external load given to the whiteboard, meaning that it pushes the bolt in the whiteboard to go out. Okay, so this is the called the external load given by P. Okay, and then Fi is the national load, At is the thread. Okay, you get the equation, give in the equation, you get put all the values from the equation, you get 72.17 kpsi. Okay, solution B, the torque necessary to develop preload using equation 8 to 7. Remember, they have you have two equation, 8 to 7 and another one 8 to 6. Okay, you want to develop the preload. Okay, the torque to the preload, where the value that you get now, you put in the range. Okay, you put in the torque range, so that torque range can give the necessary value over to it. Okay, so the SEA minimum flow strength of the ball is SP equals to 85 kpsi. Okay, meaning that from the catalog from the company, when you buy the ball, you have the catalog from the company. The value given is minimum flow strength is given is 85 kpsi. Okay, the preload and survey load stress respectively 21 and 15% less than the proof strength. Okay, so from the equation 8 to 7, the torque necessary to achieve this preload is K, T equals to K. Remember, K is the stiffness coefficient. Okay, Fi initial load, and D is the diameter. So you get this value, you put this value, you trace back what is the value given, and then you get this value 3750 pounds inch. Okay, solution C, the torque necessary to develop the preload using equation 8 to 6. Remember, you have two equation, to 8 to 6 and 8 to 7. The previous slide, we are doing the 8 to 7. Okay, now in this slide, we are doing 8 to 6. Okay, so the minor diameter can be determined from the minor area 8 in table 8.2. Okay, if you have the textbook, you can see what is table 8.2. Okay, then thus dr is the root diameter is 4 okay, square root of 4a r pi over 5. So you get this equation, you get the put all the value, you get 0.6683 inch. So the mean diameter is dm. Okay, equals to 0.5 plus 0.6685 over 2. So you get 0.7093 inch. So the lead angle is this. Lead angle, may I remind you, this is the lead angle. Okay, lead angle, where you can measure the angle each at this point. Okay, at this point, this is the lead angle. Okay, so tangent. Okay, tangent, you put all the value, you get 1.6 degrees. Okay, for alpha equal to 30. Okay, alpha equal to 30, this is the alpha, the angle. Okay, the lead angle is the beginning, the alpha is the angle, the most angle that you can see in all your bolt. If you have the bolt, any bolt with you, you can understand what I'm saying. Okay, meaning that I suggest you, when you are doing this question and all the topic about screw, you have the bolt, with any kind of bolt with you. Okay, whether it's a toy, whether it's anything that you can find, because you can study. Okay, you can see what I'm saying. So this gives the torque equals to all the value given, put all the value, trace back all the value that you can get, and then you can get the value 355.1 pounds per inch, which is 5.3% less than the value found in part B. Okay, so you have two options to put the value torque in your range, okay, in your torque range. Then you can use both, is necessary. Okay, both value is valid. Okay, the value that you get, you insert the value in the torque range. Okay, that is all the video for this video. Okay, so we see you in the next video on 8.9 statically loaded tension joined with preload. Thank you very much.